Hello, we are students from Unimas and we are going to present about agronomic practice in oil palm.
Hello, my point is fertilizer management. Fertilizers are crucial for the growth of oil palm. Healthy oil palm will produce optimum FFB yields, which stands for fresh fruit bunch yield. Proper management of fertilizers need to be considered to supply adequate nutrients to the oil palm in a balanced proportion. The key steps are: first, you need to determine the growth and the target yields. Second, you need to assess the nutrient requirements and prevent occurrence of nutrient deficiency. Third, you need to assess the resource and management level of the estate. Fourth, you need to choose the most efficient and cost-effective fertilizers and the application of the fertilizers. And fifth, compute the expected result. And last but not least, decide for the action required and repeat the step if necessary. In conclusion, fertilizer management are highly essential, not only in supplying adequate nutrient requirements to the oil palm, but also in minimizing the production costs, as fertilizer constitute about 24% of the total cost of oil palm in Malaysia.
Hello everyone, I'll be presenting about water management, one of the agronomic practice in oil palm. Water management is a crucial aspect of oil palm cultivation as deficit or excess water stresses oil palm trees and is highly detrimental for crop yields. Water management in oil palm fields aims to minimize impacts of drought and flood, optimize use of rainwater and surface water, maximize utilization of effluent from palm oil mills, and minimize impacts of saltwater incursions and acidity levels. Water supply or water source to oil palm cultivation shall be obtained from sources that are not exposed to any contamination risk. Drainage system is crucial to remove excess water and promote oil palm root proliferation in deeper soil layers. Topography surveys are conducted to ensure effective planning of drainage and irrigation system, such as identifying water gates and flood pond areas. For coastal estates such as peatland, a systematic drainage system or bunds are constructed to remove excess water or prevent floodwater from entering estates during high rainfall period, especially in Malaysia during the monsoon season, which is in between months of November and January. Optimum depth of water table for oil palm growth is 50 to 75 centimeter, proposed by American Palm Oil Council, which is also known as APOC. Optimal water levels are maintained through a system of water gates and flood pumps. So a good drainage system consists of a main drain, collection drains, field drains, and a water gate. So here is a good drainage system design proposed by Malaysian Palm Oil Board, which is also known as MPOB. And here is another good drainage system design proposed by MPLB also. So a field drain serves to connect to collection drain for infill water reticulation, and the specifications of field drain suggested by MPLB is with width of 1 meters time depth of 0.5 meters. And collection drain is served to connect to main drain for in-block water reticulation, and the specifications recommended here is also with width of 2 meters times depth of 1 meter. The main drain serves to channel excess water from plantation area collected by field drain and collection drain to overflow water gate or to canal, and the specification suggested by MPOB is with width of 4 meters times depth of 2 meters. And water gate is to maintain sufficient water in a canal and drain at all times, especially during dry season. And the density of watergate establishments uh, proposed by MPOB is one watergate for every 25 to 50 hectare of oil palm plantation field. On inland soils and undulating hilly terrain, water management are critical because growers need to maintain soil moisture and minimizing soil erosion and nutrient losses. So the water management methods on hilly terrain includes construction of terraces, appropriate front stacking method to minimize the velocity of water runoff downhill slopes, and the establishment of legume cover crops on the terrace fringes to replenish soil organic matter stock and reduces soil and water movement velocity. The legume cover crops commonly established in oil palm estates include species such as Mucuna bracteatia, Ferraria fasciculoides, and Calapogonium cerealium. And all these methods will help to minimize surface runoff, resulting in high water retention. And thank you.
Wheat is a plant that is considered undesirable that grows where it is not wanted. Wheat management is very important, especially in oil palm plantation. The moist environment in peat favors luxuriant growth of wheats, especially in the areas of high rainfall. Most of the early wheat species are indigenous species with zero burning, predominantly the ferns, hedges, and wood species. The wheat management on harvesting pot and circle weeding of palm suckle must be carried out without delay. The suckle weeding can be carried out with various types of knapsack sprayer. The selection of spray equipment and herbicide must be based on cost effectiveness and labor efficiency, protection for workers, and minimal environmental effect. Furthermore, before the weeding works, calibrating and checking should be done to ensure the correct dosage of herbicide to be utilized. To minimize the weed succession problem, timely spraying of noxious weeds with selective herbicides should be done to promote the development of suitable ground cover. Clean clear weeding that decrease the population of natural enemies against leaf-eating caterpillars, such as the predators and parasitoids, should be avoided as it may lead to outbreak of nettle caterpillars and bagworms. Wheat can grow very fast in peat areas, and any delay or neglect in wheat management will lead to rapid degradation of field conditions, especially in immature areas.
In agriculture, pests are organisms that damage crop by their feeding or burrowing activities, and diseases involve microorganisms like fungi, bacteria, and virus. It damages the crops by disputing the plant's physiology, metabolism, or direct cellular and tissue damage, and the crop ability to optimize the production. The major pests of oil palm in Malaysia are rats, bagworms, nettle caterpillars, rhinoceros beetle, bunch moth, and termites, while the most important disease is Ganoderma basal stem rot, and to a lesser extent marasmus bunch rot. Integrated pest management, or IPM, is the use of holistic and compatible method of pest and disease control to reduce economic injury to the crop. IPM remove the overdependence on pesticides, making the process more sustainable. There are some integrated pest management methods that can be used to control pest and disease outbreak. For example, by planting the beneficial plants such as Cassia cubaensis, Tundra subulata, and Antigodon leptopus to provide shelter and supplementary food such as nectar and encouraging the population of predators and parasites. Biological control such as pheromone trap also being used beside the rhinoceros beetle breeding site by sprayed with Metarhizium anisopliae. That's all for me. Thank you.